In the previous video, we learned how to recover replicated virtual machines. Since replication causes a lot of network and data traffic, it's always good to look at ways to optimize replication. We can optimize replication with Network I/O Control version 3. This is available in the VMware Distributed Virtual Switch. We can use traffic filtering and marking capabilities, as well as manipulating VM kernel adapters to separate management traffic from data traffic. So we are back again into our vSphere web client. We are looking at the distributed switch that is part of the vCenter server 220. And the reason I want to show you this is because we're going to look at first of the three ways in which one can optimize traffic for replication as well as for data protection. So the first way to do it is to use the Network I/O Control version 3 capabilities that are available with the distributed switch version 6. This topic has been covered in the section that deals with vSphere virtual networking. But since we are talking very specifically about a very specific usage of that, it's a good time to review that to be sure we understand how it would apply for replication traffic and for data protection traffic. So I click on the distributed switch, click on manage, and I look at resource allocation. Now this is where there are two things one can look at: system traffic as well as network resource pools. We've covered network resource pools before, so we're going to look only at system traffic. Now when I click on system traffic, you will see that the traffic types here are all system traffic. They range from vSphere replication traffic and data protection traffic, which we are going to get to in just a minute. And then, of course, all the other system traffic of vMotion, iSCSI, vSAN, the virtual machines, the NFS, the management traffic, of course, and then fault tolerance if that is in place. Now, my distributed switch has Network I/O Control enabled, so that has to be enabled at the switch level. As you can see, it's version 3, so it works differently from prior versions. I have a physical network adapter with a speed of 1000 megabits, that's 1 gigabit per second, which means that the total throughput available through that VM NIC is 1000 megabits per second. Now the rules of the game with Network I/O Control is that out of the total bandwidth capacity of 1 gigabit per second, I am allowed to configure reservations of 75% of that, which is basically 750 megabits per second. What has been done is that I have configured reservations already have been configured of 750 megabits per second, and you can see that by adding this up. So it's 500 and 250 is 750 megabits per second. So it leaves the available bandwidth for other kinds of activities of 250 megabits per second. So system traffic, data protection, and vSphere replication traffic are both system traffic types. So what is possible to do here is to actually define what the share values and the reservations are for these. So by clicking on, say, vSphere replication traffic type, pencil comes up and I click on the pencil, and there I can define the shares, I can define the reservations, and I can define the limits for vSphere replication traffic. So this allows me in a very granular and meaningful way to specify the minimum, which would be in our case the reservation for vSphere replication traffics, and then in cases of congestion we're leaving it as normal traffic. It's possible you might want to actually up it to something else than normal. Probably a custom would be good, because the amount of replication traffic depends on your recovery point objective, but it also depends on the amount of changes in the VMDK for the virtual machines. So a lot of tuning possibilities exist here. So a lot of monitoring and some amount of tuning once your system is operational are necessary to make this work well. Otherwise, everything goes by default, and that's, a default generally works but doesn't work very well most of the time. Of course, you can set a limit as well. As you can see, the maximum limit is 1 gigabit, which is the full bandwidth of that network adapter, that VM NIC. but of course you can set it to anything in between as well. I've set it to 200. I'm going to cancel in the same way. We can look at the data protection backup traffic, and we can also basically limit it and police it. So we have the reservation set to 300 and a limit of 300. So basically up to 300 are reserved for it, no more, no less, for data protection backup. Now this is obviously at the entire D-switch level for this kind of traffic. And this gives us one way in which network I/O control is actually used to make sure that the right amount of bandwidth is actually available for key types of system traffic, especially in times of congestion. We now switch gears to looking at yet another way of optimizing data protection and replication traffic, and that is traffic filtering and marking. The shares value and the reservations obviously apply to the vSwitch itself, the distributed virtual switch itself. But once this traffic goes out into the physical network, if it is not marked correctly, which means every Ethernet frame on the Ethernet LAN or every IP packet on the wide area network is not marked correctly, then defaults automatically kick in. And usually defaults are that all traffic is classified and lumped together into a best effort traffic, and all the tuning you did at the virtual switch level goes by the wayside, because all traffic is then treated in exactly the same way. So to manage that, here is a distributed port group. I've called it data protection, can be any name, that we are going to take a look at its settings. And we're going to look at the traffic filtering and marking settings. In a previous section of this course, we have covered traffic filtering and marking extensively, but just as a review, there are two types of markings that are necessary, because when traffic comes out of the virtual switch, out of the virtual environment, out of the ESXi server, it goes into a physical switch and is usually an Ethernet packet on the LAN for quite some time. That packet can be marked with a classification called class of service. It is basically a tag that specifies how important or not important that packet is. There is another marking called the DSCP marking, differentiated services code point marking, which has also been covered extensively in a prior section of this course, which is really meant for the wide area network. So when the IP packet starts to be routed, the IP packet also is marked with some kind of a marking that tells the routers the level of importance of that IP packet. So there are two types of markings that are needed out in the physical network. One is for the LAN and one is for the wide area network. One is for the Ethernet frames and the other is for the IP packets. So there are two previous examples that have been set up here. As you can see, the action for the first rule of traffic is to set it at class of service 4 and a DSCP of 4. It's usually in the range of 42, 44, 45, 46, but this is just for illustration purposes only. So let's click on the plus sign and see whether we can add a new traffic rule 3. So what we're going to do is we're going to update the class of service tag to say 5 and the DSCP tag to maybe 46. The class of service tag is for the Ethernet frame and is valid on the LAN. The DSCP tag is on the IP packet and is valid on the wide area network. Now, these settings should be done only in conjunction with the networking organization, because while Cisco and other vendors, networking vendors, have different standard rules for these, they have become standardized in many ways across vendors, but it's good to make sure that those standards or some local standards are being followed in your organization, and the best people to actually explain to you what the tagging should be for class of service and for the differentiated services code point out in their network are the networking people. So please contact the networking organization before tagging this. Now, what is it that we are going to tag? Well, we are going to look at system qualifiers. Okay, so if the system traffic type is or is not, so we just say is if it's vSphere replication. Okay, I don't worry about the source port and so on. So really all we are saying right now is that if there is system traffic, that is vSphere replication traffic, mark the class of service tag as 5 and update the DSCP tag to 46. And this takes care of this data, replication data, as it traverses the local area network and the wide area network. You can see how important this is because you don't want it immediately after leaving your ESXi host to be dumped into a common bucket with all the rest of the traffic, some important and some not so important. Especially if you have a separate backup network, a separate replication network serviced by independent physical NICs or VM NICs, that is obviously the best thing to do. Even in that case, if you expect no other traffic to traverse that network, it's always good to be consistent and mark the traffic appropriately. There is yet another way that needs to be looked at. Because the replication appliance and the data protection appliance are virtual machines, we have the ability to add multiple VNICs. By adding multiple VNICs, it gives us the ability to separate out the various types of traffic. We can separate out the management traffic from the replication traffic. And in fact, the appliances allow you that capability where you can, for example, on the replication appliance, you can go in there, add a virtual NIC, and when you go to configure it, you can define that new NIC at a new IP address to basically be the NIC to be used for incoming replication traffic, while the original NIC, that was the VNIC 0 for that virtual machine, would still be used for management purposes. So you would separate out the management traffic from the replication traffic. Always a good idea. So that is obviously done by, for example, in a distributed virtual switch, you add and manage hosts, you manage host networking. We need to add a new VM kernel. I'm going to take this host, verify that's the host. I'm going to only manage VM kernel adapters, and I'm going to add a new adapter. I'm going to select an existing port group, for example, my data protection port group, and I'm going to click OK on that. Click Next. And this is where we have the ability to specify that this VM kernel is going to be used only for certain purposes. So let's look at this. vSphere replication traffic and vSphere, so that would be basically your management traffic, and then you have the replication traffic is your network file copy where the actual replication traffic goes through. So management traffic for replication, and then the actual replication traffic for the virtual machines. So you can create a VM kernel adapter that's specifically for NFC traffic, and then you can assign it an address, an IPv4 address in this case. And what that allows us to do is to actually then have on the virtual appliance, on the replication virtual appliance, we have then the ability to create a new virtual NIC and then assign that NIC an address that is in the same subnet or network as this VM kernel. And when that is the case, the kernel, ESXi kernel, basically uses that VM kernel to connect with the incoming traffic assigned virtual NIC that is on that replication appliance. So not a difficult thing to do. It's documented quite well in the vSphere replication documentation center. They have sections on isolating the network traffic. Basically, you dedicate a VM kernel NIC on each ESXi host on the primary side that is sending data to the replication server, and you are then able to distinguish between the various types of management traffic. 3 types of traffic in a vSphere replication appliance, which has one VM network adapter, basically is traffic, which is between the management server and the replication server, replication traffic from the host to the replication server, and then traffic between the vCenter server and the vSphere replication management server. And the recommendation is to add network adapters to the vSphere replication appliance, and then use the WAMI interface to configure a separate IP address to use for each traffic type. So basically add more virtual NICs to the appliance, and then make sure it's in the same network as the VM kernels that you have created for specific service types like we have done here, which is vSphere replication NSC traffic, and probably in this case vSphere replication traffic would probably be okay as well. So 3 ways in which the actual traffic for protection and replication can be optimized. One is network IO control version 3. The other one is network filtering and marking with the class of service and differentiated services code point markings. And then with this for replication, one can define VM kernel adapters that would carry that kind of traffic, and then add more virtual NICs to your replication virtual machines to be able to be on the same network and connect with these kernel adapters so that the traffic can be routed directly to those additional VNICs. In the next video, we will look at vSphere Data Protection Appliance installation and configuration. I look forward to seeing you there.